Hello everyone. In this video, we will be discussing about antiderivative of algebraic functions. Algebraic functions are functions like constant function, linear function, quadratic function, radical function, rational function, or more functions. Now, in answering antiderivative problems, we are actually guided by theorems under antiderivative. Now, other books are using the term antidifferentiation or integration, but I am using here the term antiderivative. Okay, let me give you an example of antiderivative given an algebraic function. For example, number 1, if I have here integral of dx, find the antiderivative value. Now, from this problem, we are given with one of the theorems in antidifferentiation, such that if you have integral dx, the antiderivative is x plus c. In short, if I have here integral of dy, okay, so our function is now respecting to a y variable. So if you have integral dy, then this is y plus c. And then if you have integral dz, would be z plus c. So your answer is actually dependent on what variable does the function is respecting to. Now, if you have here integral dx, this is now equivalent to x plus c. This is now our answer in referring to one of the theorems coming from antidifferentiation. Another example, if I have here number 2, anti-differentiate or get the antiderivative of x dx. Now, from this example, we will be using another theorem coming from antidifferentiation. Assuming if I have here x raised to the power of n dx. This is being read as integral of x to the n dx. Our n here is an exponent coming from the x variable. And we have here dx notation. Now, as you notice from our given problem number 2, this is understandable that the n value here is 1. And so if you have integral of x to the n dx, the answer would be given as x to the n plus 1. So all you have to do is to add 1 from your exponent n over n plus 1 plus c. Now our n here should not be equal to -1, otherwise your denominator will become 0, and that's undefined. So as you notice from our pattern, we add 1 from our exponent n, and whatever the sum will be the denominator. So this is what we're going to do from this problem. So this is now x raised to the power of 1 plus 1 over 1 plus 1 plus c. So this is now equal to x squared over 2 plus c. This would be our answer. X squared over 2 plus c. Using this theorem coming from antidifferentiation. Another example. Assuming I have here 2x to the 4 dx. Now, our goal is to find the antiderivative of the integral of 2x to the fourth dx. Now, from the theorem under antidifferentiation, first thing to do is to let the constant out from the integrand portion. So this is now 2 integral of x to the fourth dx. And from this point, we will be using the theorem that we are going to add 1 from our exponent 4, okay, such that if you have integral of x to the n dx, the equivalent antiderivative will be x to the n plus 1 over n plus 1 plus c. So this is now the theorem that we are going to follow in answering the integral of x to the fourth dx. So this is now 2 times. We are now going to omit our integral symbol. And then following this theorem, this is now x raised to the power of 5 over 5 plus c. Multiplying both numerator and both denominators, so this is now 2 x to the fifth over 5 plus c. This is now our answer. Another example, it's possible that our integrand is given by this function 2x to the fourth plus x dx. Okay, first thing to do is that we are going to distribute dx to the first term and to the second term. So this is now integral of 2x to the fourth dx plus integral of x dx. Take note, this is one of the theorems in antidifferentiation to use in getting the antiderivative. Continuation, we are going to let our constant out. So this is now 2 integral of x to the fourth dx plus integral of x dx. Now for our first term and second term, we have to follow this formula. So this is now 2 times x raised to the power of 5 over 5 plus, understandable that our exponent here is 1. So this is now x squared over 2 by following the same theorem. And then do not forget to write plus c at the end portion of your answer. So this is now equal to 2x to the fifth over 5 plus x squared over 2 plus c. This is now our answer. Another example, if I have here 4th root of x to the 5 dx, this can be written as integral of x raised to the power of 5 over 4, which means that when you say 4th root x to the 5th, 4th root is just equal to 1 over 4 times 5, so it becomes 5 over 4. And then we have here dx. So it's possible that you will be writing a parenthesis or not. But here we are now using one of the theorems such that we are going to add 1 from our exponent, and then whatever the sum, that would be your denominator. So this will become x raised to the power of 5 over 4 plus 1 over 5 over 4 plus 1 plus c. Simplify 5 over 4 plus 1. This will be equivalent to x raised to the power of 6 over 4. I'm sorry. This is 9 over 4. 9 over 4 all over 9 over 4 plus c. But when you say x raised to the power of 9 over 9 over 4 plus c, you have to multiply the numerator with the reciprocal of the denominator. So this is now 4x raised to the power of 9 over 4 over 9 plus c. This is now your antiderivative. Another example. Assuming you have here 2 over x to the 5th dx. In this case, your integrand would be 2 over x to the 5th. And by using the law of exponent, you are going to bring up x to the 5th to the numerator. From positive 5, it will become negative 5. So this is now integral of 2x to the negative 5 dx. Letting out the constant from the integrand, so this is now equal to 2 integral of x to the 5th dx. Following one of the theorems such that we're going to add 1 from your exponent. So this is now 2 times x raised to the power of negative 5 plus 1 over negative 5 plus 1 plus c. Simplifying, this is now 2 x, negative 5 plus 1 will be negative 4 over negative 4 plus c. But we can actually cancel 2 and 2 here. So 2 over negative 4 will become 1 over negative 2. So this is now x to the negative 4 over negative 2. But you can write negative in the middle portion. Plus c. No negative exponent, so you have to bring that down again. So this is now negative 1 over 2x to the positive 4. If you will let x to the negative 4 be on the denominator, from negative exponent it will become positive. So what's left in the numerator will be 1 or negative 1 because you have negative plus c. This is now your antiderivative. Thank you for watching.